All right. Our next speaker is Markus Kitsinger with the iRODS Consortium, and he's going to talk to you guys about iRODS build and packaging update.
Howdy, I'm Markus. I'm a software developer for iRODS. My main focus is on the build system and packaging, and that's what I'm here to talk about. So we're going to talk about our external dependencies. We're going to talk about the packaging for our external dependencies. We're going to talk about the build system for iRODS, and we're going to talk about packaging for iRODS. And first, we're going to talk about the current state of affairs. Why things are the way they are, like the reasons that we did the things that we did, and the problems that we've run into as a result. We're going to talk about the new approach that we're going to be taking, and all of the friends we're going to meet along the way. So just a quick overview. We package our external dependencies with FPM. We build iRODS with CMake and package it with CPAC. And everything is built with Clang and libc++ that we provide as an external package that is also packaged with FPM. And we support Debian and RPM packages. So let's talk about our externals. Our externals are a set of separately packaged dependencies. It's third-party code that we depend on. And we have a directory that we put them in by default. It is standard for all of our externals packages. And we do this because not all of distributions have what we need to build iRODS and run iRODS. And sometimes even if they do have the right packages, they might not have a new enough version. And there's another reason that I'll touch on in a minute, but those are the main two. So here's some caveats. The externals are not really well integrated into the system. That can be seen as really either a pro or a con, depending on where you're coming from. We are currently not set up to provide different sets of externals for different distributions. So, for example, Ubuntu 20 provides a version of Leuven JSON that is new enough for us to use. But since we can't provide Leuven JSON on CentOS without also providing it for Ubuntu 20, we provide it for Ubuntu 20. And our current build system for iRODS relies pretty heavily on how our externals are packaged, where different files live, the directory structure, that kind of thing. And we'll touch more on this in a bit. So let's talk about libc++. So like I said before, iRODS and most of our externals are built with Clang, and everything that's C++ is built against libc++. And we provide both the Clang and libc++ that we use in our externals. And we do this because we need a newer Clang and libc++ that is available in some distribution repositories. And for historical reasons, way back when we originally started first using Clang, it was way ahead of GCC in terms of adoption of new C++ standards and compiler features and that sort of thing. So as a result, a lot of our code is not really GCC friendly because we've just never really thrown it in GCC to see what happens. We have as recently, that's how we found out it wasn't very GCC friendly, but up until recently, it just hadn't happened. So let's talk about some caveats for libc++. You can't really mix binaries that are compiled against libc++ and libstandard C++ without jumping through a bunch of hoops. You just don't want to deal with it, honestly. And distro-provided packages usually use libstandard C++, at least on the distributions that we support. And because of that, that increases the number of externals that we must provide. Even if every distribution provides a usable version of a package that is a C++, uses C++ to build, we can't use it because they looking against the wrong standard library. And it also makes building against iRODS more complicated, because if you're building against iRODS, you also have to use libc++, and any other third-party libraries that you pull in that you want to use also have to use libc++ instead of libstandard C++. It's a whole thing. So let's talk about our packaging. Like I said before, iRODS is built using CMake and packaged with CPAC, and our externals are packaged with FPM. For the iRODS build system, the build system does a lot of the platform-specific heavy lifting, and most packaging is defined in CMake. So that's where we set all of our package dependencies for each distribution and that sort of thing. And when we handle file and directory ownership programmatically with post-installation scripts so that we can make sure that different things are owned by the iRODS service account, or whatever you happen to name it when you set up iRODS. We put our libraries in USRlib, regardless of what the distribution expects. So for example, on CentOS, the libraries would usually go in USRlib 64. That's where all the packages put their libraries, but we don't do that. So we use CPAC and FPM because they're good. They're decent enough one-size-fits-all solutions, and they're easier to wield than depackage, build package, and RPM build. And at the time that we chose these tools, our approach was lazy but sufficient. So let's talk about some problems. We can't provide Debian or RPM source packages when we're using CPAC and FPM. And then there's the service account shenanigans that I mentioned earlier with the file and directory ownership. I refer to that later on as service account hot potato. And since we rely on our externals so heavily, it's kind of difficult to use system provided dependencies instead. And it often requires changes to the build system itself. We also don't have package linting, such as Debian's Lentian, or however you pronounce it. And we can't do start from zero builds, which is where you have your source package and you throw it at a container that's got the bare minimum for building packages installed. And it looks at your source package and sees your list of dependencies and goes ahead and installs it for you before actually building the package. One of the tools to use that is called pbuilder. That's what is usually used in the Debian world. So it turns out lazy but sufficient is neither, or at least it has become neither, because we need to provide Debian and RPM source packages. And the service account hot potato means no systemd unit files in the packages. And people have been asking for both of those things. And CMake has to know a lot about the target distributions to produce usable packages, and we have to specify all of our dependencies manually. We can't use utilities like the ones that Debian provides to automatically look at the libraries that we're linking against and generate package names to populate dependency fields. Adding support for another distribution requires a lot more work as a result, and a new release. And the same goes for if we're adding support for a new version of a distribution that we already support, because you have to go in and add all those dependencies and make sure that everything ends up in the right place and that sort of thing. And we want to reduce the number of external packages that we provide. For example, again, nlm and JSON and the boost. Like there's some distributions that we support that have a new enough boost for us to use. And we also can't benefit from automated symbol tracking. Debian has a utility for this as well, where it'll look at the symbols in your library and compare them to the symbols from the last version of the package to make sure that you're not breaking ABI compatibility. So here's where we're headed with our packaging. This is the new approach. We're going to shift to using the standard tools, this depackage, build package, and RPM build for packaging. And we're going to use get build package to maintain our Debian packages in the same way that Debian themselves do on their Salsa GitLab instance. We might also be using it for our RPM packages as well. We're still investigating. We won't provide externals packages if there's already a perfectly usable package in the distribution repositories. We will provide source packages in our apt and RPM repositories, so they can be pulled down with the standard tools in the standard way. We will install our libraries in the normal locations instead of having everything in USRlib regardless of distribution. And we will provide default systemd units that can be overridden by the administrators piecemeal. And we will also build against lib standard C++ so that we can use the system provided boost and that kind of thing. And we will decouple the iRODS build system from the externals packaging implementation details so that it's not so difficult to, say we want to build against a different library that lives somewhere else. And here's some of the friends we're going to meet along the way. My packaging experience is mostly with Debian, Arch, and Wix toolset. I don't have a lot of experience in RPM land, so I'm still getting familiar with RPM build and the instrumentation surrounding it. We will also need a new workflow and instrumentation for building packages, and we're going to need separate workflows for the from zero builds, like I mentioned earlier, and the routine development builds that can take advantage of cached compilation units and that kind of thing. Surface account hot potato is actually part of a larger issue that is going to take some care to solve. We're going to have to move a bunch of files around and make sure that only the stuff that needs to be owned by the surface account is owned by the surface account and no more. And it's just going to have to be really careful that we don't break anything when we do that. And distributions without a new enough libstandard C++ will need a libstandard C++ externals package. Possibly GCC as well, but I doubt it. We will have to write CMake find modules for non-CMake dependencies that do not already have them. And we may also have to write CMake wrapper modules to work around bugs in CMake provided find modules like the find.odbc.cmake, which doesn't really give you an option for prioritizing one implementation of ODBC over another. And the biggest one of them all is that we can't really break this whole thing up into stages or phases, and push up the changes a little bit at a time. It's kind of going to be an all at once kind of thing, and because of that, we don't really have a timeline. There's a lot of work to be done, and a lot of steps between point A and point B, a lot of known unknowns. And I'm thinking we might have a better idea of the timetable at the next UGM, but I'm not really sure. Any questions?
All right. Thanks, Marcus.